Okay, 7.1 roots and radical expressions. So the first thing we're going to do is go ahead and define some of the things we're dealing with. So the first thing is the radical. That is this symbol. So that symbol is considered the radical. Okay, and then your radicand is the number under the radical. And the index is the number that tells the degree of the radical. Okay, so let's label over here. We have our radical. We have the index telling us the degree of the radical, and then this number is the radicand. So the number under the radical, the radicand. Okay? So now you know when we're mentioning these things which thing we're talking about. Roots and powers are inverses. So we talked a lot when we solve equations, always, when we say we have x squared equals 16, we always say, well, how do you find the square root, or how do you undo a perfect square is the question we always ask you. How do you undo a perfect square? I'm trying to get x by itself, so I need to undo the fact that it's been squared, and you do that with taking the square root, right? We've done this a lot, and so we know that the square root and the perfect square are inverses of each other and they cancel. So this is an important thing to know because you can use this with all different kinds of radicals. So for example, if I have an x to the third power, then I'm going to take the third root of it so that they cancel and I'm left with x. Or if I have a fifth power, I'm going to take the fifth root of it so that they will cancel and I will be left with just the variable. This also works in the reverse. In other words, if I have a sixth root and I need to get x out from underneath that root, then I'm going to raise it to the sixth power. You're just doing it in the reverse order, and you're left with 6. If I have the ninth root of a variable and I want to get it out from under the radical, I raise it to the ninth power, and I get the variable out by themselves. So they are inverses of each other. Okay, so the index and the power with which you raise something are indexes of each other, or inverses of each other. Okay? All right. Now, let's talk a little bit about the signs, plus or minus, for different roots that we're working on. So this is a little bit tricky and can sometimes be quite confusing for students. So let's take a moment and just evaluate what happens in this equation. So I'm going to tell you that we're going to do the square root of x to the 6th. Okay? And so by our definition, we should be able to get 3 groups, 6 divided by 2. That should be the same thing as saying x to the 3rd. Okay? So those are equal. I think everyone agrees that those would be equal sentences. I want you to evaluate this for when x is equal to -2. Okay? So let's evaluate it with x equals -2. So we're going to do the square root of -2 raised to the 6th. And then on this side of the equation, we're going to have -2 raised to the 3rd. Okay? So underneath the radical, -2 times -2 times -2 times -2 times -2 times -2 gives me 64. So I have the square root of 64. And on this side, I get -2 times -2 times -2. And that gives me -8. Okay? So let's continue. What's the square root of 64? Well, we know that is 8. So 8 does not equal -8. And so I know some of you are saying to yourself, well, the -8 times -8 gives me 64. So what you're saying is when we do the square root, okay, we know that the answer is plus or minus 8. But the radical, you need to know this, the radical indicates what we call the principal square root. Okay, the radical indicates the principal square root. That means the positive answer. They only want the positive answer. Okay? And so if that's the case, if radicals indicate that they want the principal square root or the positive value, then we're going to have to do something about the fact that we're getting negatives in our answers. And so you do that, you fix it by taking the square root. Okay? So we're going to have to take the square root, sorry, not the square root, the absolute value. We're going to have to take the absolute value of our answers to ensure that this happens. So this situation happens when our roots are even. Okay, so when we have even roots, sometimes we get odd answers out. Okay, so for example, if I have an even root, so this is even, and my answer comes out as an odd power. Okay, so we just said that when x is negative, so when you have a negative value that you want to plug in to this x, it is going to not work on the other side of the equation. It's not going to calculate out. So we can't use the negative value. So when the variable comes out with an exponent that is odd, to ensure that we're only using the positive value, because that's the only one that's going to work, then we have to take its absolute value. So take absolute value to ensure the principal square root. Or just we'll just call it the principal root because it's not always a square. It's an even root. So when n is even, this is the important part. When this is even and the power comes out as odd, that's when you have to take the absolute value. Okay? When the index is even and the power that comes out as is odd. Okay? Take the absolute value. All right, so now we're just going to practice three examples, and then you're going to go and work on some by yourself and see how you do. So some of you might already know the square root of 4 is 2, and some of you might have picked up on the fact that I mentioned earlier that when you have a value of 6 underneath the radical, and this is a square root, I'm looking for how many groups of 2 are there in 6, and we know that that's 3. That's essentially a division problem. So we think about this, we're breaking this down, right? And we have 2 squared, and then if I break down my groups of my x to the 6th into groups of 2, 2, 4, 6, I end up with 3 of them. And since these are all perfect squares, they all come out of the radical, and I get 2x to the 3rd. So essentially here, I did 6 divided by 2, and it gave me 3. So you can kind of use division to help you with the variables. And so the only thing you need to check before you're done is this was even, so the index was even, and the power that came out was odd. So I do need to take its absolute value. So you put the absolute value symbols just around the thing that has the odd power. And we only do that for variables. We do not do it for the actual coefficients in front. Okay? The numbers under the radical are fine. We just do it for the variables. All right. So if we're going to use that whole division idea, this one should be 3 divided by 3. So I should get a to the 1st. And my b term is a 6. And 6 divided by 3 should give me b squared. So let's test it and see if it works. Just be sure. So my a to the 3rd I'm going to leave that way. And my b to the 6th I'm going to break up into groups of 3. So 3, 6. Now those are all perfect cubes under a cube root. So they all cancel. And all of those come out from under the radical. And then I'm going to simplify. A times b squared. And so I do get a times b squared. And since it's an odd radical, I don't have to worry about doing any absolute values. I only do that for evens. So there's my answer, ab squared. The third example, again, if we use the division, 4 divided by 4 is 1, so x to the 1st, and 8 divided by 4 is 2, y squared. The x is an even, and that came out as an odd power. So even odd means I need to do absolute value. Notice I only did it around the term that had the odd exponent. So there's your answer. The absolute value of x, y squared. You do not need to write that power of 1 if you don't want to. A lot of students like to put it in there so they don't forget, and it helps them to not miss any of those odd values. So that's your answer.